Modern enterprise architecture relies on centralized layers for data, compute, and integration. But look for a dedicated layer for business decisions and human policy, and you won't find one. The logic governing the business is scattered, buried inside individual microservices. A single pricing rule or compliance check rarely lives in one place. It is often duplicated across customer portals, billing systems, and back-office applications. When a regulation changes or a contract is renegotiated, engineering teams must manually hunt down and update every instance of that rule by hand. This shows how manual patching separates a policy from what the system actually does. The top line is the authoritative document. The bottom is the code. This divergence is policy drift. Every undocumented exception tangles it further into policy debt, an unrecorded liability. This debt compounds. Each change makes the next one riskier until the organization reaches a point where it can no longer update its systems safely or quickly. When policy is managed as paperwork while it governs live systems, the organization loses the ability to prove exactly how its most important decisions are being made. Large language models collapsed the traditional cost structure of coding. The barrier between human intent and machine execution has effectively vanished. The effort required to translate dense human text into executable logic has dropped toward zero. What once took weeks of analysis can now be produced in minutes. This graph shows the resulting economic inversion. As the cost of producing logic falls, the cost of validation becomes the new ceiling. The challenge is no longer writing the code, it is proving the code is faithful to the policy. Facing this shift, many organizations are taking a shortcut, prompting LLMs to reason through a policy at the exact moment a live decision is needed. At runtime, an LLM is improvising. Because it is probabilistic, the same case can result in a different decision depending on the version of the model or the framing of the request. This destroys the deterministic guarantees required for compliance. A governed decision must be repeatable, yielding the same result for the same facts every single time. Runtime AI introduces a silent, case-by-case form of policy drift that is almost impossible to observe or audit. Using AI within a build-time engineering pipeline allows us to leverage its speed while keeping the final decision logic strictly deterministic. The solution is to move AI out of the decision path and into a centralized compilation process. This starts with the source principle. The human-authored document is the permanent system of record. As this diagram shows, the executable code is merely a byproduct. When policy and code disagree, the document wins. The code is disposable because it can be regenerated at any time. This leads to the compilation principle. Executable policy is compiled, not authored. We stop treating the rule base as an asset to be hand-edited. Instead, we treat it as a build output, produced through a disciplined pipeline. In this pipeline, AI is used at build time to parse the source document and extract the requirements. This is where the intelligence is spent. The model produces an intermediate representation, a structured version of the policy that sits at the center of the flow. The IR acts as a human reviewable checkpoint. It allows experts to verify what the model understood before any logic is deployed. This representation is intentionally constrained. By limiting its expressiveness, we make the logic easier to analyze for gaps, contradictions, and circular references. Finally, the IR is lowered into a deterministic binary. This is the logic that actually runs. Because the model's work is finished at build time, the runtime is entirely free of probabilistic guessing. This pipeline captures the efficiency of AI-assisted translation while maintaining the strict control of engineered software. Reliable decisions require the provenance principle. Every outcome must be traceable to the authoritative policy. The system decided is not a legal defense. Any decision that cannot be justified back to a specific clause is a liability. While AI can guess at an explanation after the fact, compiled logic produces a recorded trace of the actual reasoning used during execution. We can walk backward from a tax determination to the specific rule node that produced it. The trace continues to the exact sentence in the document that justifies the rule. This link is bidirectional. Changing the source reveals every downstream decision affected. This trace only works if the system follows the determinism principle. Determinism guarantees that if you rerun the same case with the same inputs tomorrow, you will get the exact same result. We must also distinguish between the time the system runs and the historical date the policy is being applied. By locking policy versions to specific timeframes, an auditor can reproduce a decision from 3 years ago using the rules in force then, not now. Determinism is the structural foundation. It ensures that the provenance chain leads to the same truth every time it is walked. Together, these principles transform automated decisions from opaque black boxes into provable mathematics. In the legacy workflow, updates required hunting through scattered codebases to apply patches by hand. A compiled decision layer replaces this manual patching with total system regeneration. This lifecycle loop shows the new process. When a policy changes, you update the source document and trigger a full recompilation of the logic. The pipeline regenerates the centralized decision layer, pushing the update across the entire enterprise simultaneously. This approach removes the source of policy drift. As the irregular code branch fades, only the clean line of direct compilation remains. Because there is no longer a hand-maintained codebase, there is no independent artifact that can drift away from the source text. The modernized architecture now includes a prominent centralized decision layer. Applications no longer own the logic, they simply consult the policy. This shifts the focus of engineering teams. Value is no longer found in the typing of rules, but in the discipline of proving they are faithful to the intent of the business. We are entering an era where human policy must be engineered with the same rigor we apply to the software that executes it. Policy has evolved beyond documentation. It has become the infrastructure that governs the enterprise, and it deserves to be engineered like it.